So let's continue now. We have to solve a question 15 or 16. So let's choose a question 16, for example. So over here, let's choose this pen. Okay, so now for sine inverse, the domain also is from -1 to 1. But over here we have 1 minus, this is for sine inverse of x. But over here I have 1 minus 1 over x squared. So I will take 1 minus 1 over x squared. It's between 1 and -1. So after solving, so I will take -1, -1 for all of these sides. -1, -1, and -1. So -2 less than or equal -1 over x squared less than or equal 0. Then I'll multiply by -1. Okay, all the sides, and I'll flip the symbols over here. So it will be 2 greater than or equal 1 over x squared, and here greater than or equal 0. Okay, then I'll multiply everything by x squared. Sorry, x squared. So this is 2x squared greater than or equal. We don't need this term anymore. So this is going to be 1. Okay, because x squared with x squared eliminated. Then divide by 2 and take the square root for both sides. That will give you x is greater than or equal 1 over square root of 2, and x is less than or equal -1 over square root of 2. So my domain over here for question 16, the domain, it will be from minus infinity to -1 over square root of 2. This is a closed union with 1 over square root of 2 to infinity. Okay, now we can start by finding f prime. F prime, now the derivative for sine inverse of x, this is equal to the derivative of what inside. So if this is g of x, for example, let's say it's g of x, so this is g prime of x divided by square root of 1 minus g square of x. So this is the derivative of sine inverse. This is what we have learned in the previous term. So let's find that directly. The derivative of what inside, the derivative of this function. The derivative of 1 is equal to 0. The derivative of -1 over x squared in here, that's it, -1 over x squared. The derivative for this is equal to minus the constant, which is 1, multiplied by the derivative of the denominator, which is 2x, over the denominator squared. This is x to the power 4. After simplifying, it will be 2 over x cubed. So in here, I will put 2 over x cubed divided by square root of 1 minus this function inside square. 1 minus 1 over x square square. Let's take this aside and do it. So in here, if I have 1 minus 1 over x square square, this is going to be equal to 1 minus 1 over x square square. This is equal to the first one square minus 2 multiplied by the first by the second, which is 2 over x square. Then it will be plus the second one square, which is 1 over x to the power 4. So in here, I'll go back, write 2 over x cubed all over square root of 1 minus 1 minus 2 over x square plus 1 over x to the power 4. Okay, So I will take now 2 over x cubed over, in here let's enter the minus inside, so it will be 1 minus 1, which is 0, then the minus with minus positive, so this is 2 square root of positive 2 over x square, then minus with a plus, so this is minus 1 over x to the power 4. In here, then I'll try to make the denominators the same over here, so I will use the cross method. This is going to be equal to 2 over x cubed divided by square root of, open parentheses, or no need for that, x to the power 4 multiplied by 2, 2x to the power 4, okay, minus x square over x square multiplied by x to the power 4, this is x to the power 6, in here equal to 2 over x cubed divided by, let's use the distributive property, 2x to the power 4 minus x square, now divided by square root of x to the power 6. Okay, so this is equal to 2 over x cubed multiplied by, let's flip the second one. Now square root of x to the power 6, this is x to the power 3, over square root of 2x to the power 4 minus x square. This with this eliminated. Now this is equal to 2 over, we can take x squared as a greatest common factor from the denominator, so x squared 2x squared minus 1. Now this is equal to square root of x squared, this is x, so 2 over x square root of 2x squared minus 1. Let's make this equal to 0. So in here, zeros of derivative, I will write it again over here, 2 over x square root of, in here I have 2x squared minus 1. Zeros 2 equal to 0, which is impossible. The undefined value or values over here, so it will be by making this x square root of 2x squared minus 1 equal to 0. So from this I will have x equals 0, and from this I will have 2x squared minus 1 equal to 0. So x, it will be equal to positive negative square, or 1 over square root of 2. Okay, now for x equal to 0, since our domain or the 0 is not included in our domain because it's minus infinity to minus 1 over 2 and from 1 over 2 to infinity, so in here the 0 is not included at all. Okay, now for 1 over square root of 2, they are included, so here we have critical numbers, which is 1 over square root of 2 and negative square 1 over square root of 2. So let's do the number line test. Now over here, this is my number line. I will take minus 1 over square root of 2 and 1 over square root of 2. Now the function is undefined on this value, which is between 1 over square root of 2 and minus 1 over square root of 2, the original function. I'm talking about that. So let's test the derivative over here. So I will take 2 over x square root 2x squared minus 1, calculate Now 1 over square root of 2, which is 0.7, so I will take 4 as a value greater than 1 over square root of 2. So this is going to be positive, and value less than minus 1 over square root of 2, I will take, let's say, minus 4. This is negative. Okay, so in here, so I have negative and I have positive, and here nothing, undefined, the function is undefined, so increasing from 1 over square root of 2 to infinity, and decreasing from minus 1, or sorry, from minus infinity to minus 1 over square root of 2. This is my question. That's it. This is my answer. So this is the increasing interval and the decreasing interval. Okay. So next, inshallah, we'll talk about rational function and square root function. So see you then.